In this video, I will explain how you solve this vector multiplication question and this planes question that you see in front of you. So we have two vectors denoted as A and B, with A representing this vector and B representing this vector. So first of all, we must find A cross B. And second of all, we must find the equation of a Cartesian plane which contains A and B as the two vectors and also passes through this point 1, 0, -1. So let's start with part A. So A cross B means we have to cross I minus 3j minus 2k, and that's crossed with minus 3j plus 2k. So while there are multiple ways to perform this cross product of these two vectors, this is the method I follow. So we know that I, j, and k are the ways to represent the different components of each vector in terms of their x, y, and z values. So first we must form this cycle. So I goes to j, j goes to k, and k goes to I. Let me just draw that better. So now when performing this multiplication, if we cross an I value with the j value, the end product must be the product of the magnitude of the two components, but must have the letter that comes after. So for example, if we cross I and j, so that's I cross j, we get k because of this cycle where I, then j, and then that goes to k. Then if we go the reverse direction, I cross k. Now, because we're going backwards in this clockwise cycle, we do still get j, which comes after k in this side. However, it is going to be negative as we're going backwards. Similarly, if we do j cross k, because j, k, we then get I, and then again k cross j, we get minus I, because you're going from here to here and then backwards in this clockwise cycle. Now it should be noted that if you are crossing the same components, so I cross I, you come back to the same place, and therefore that equals 0. And if you're crossing I times I, or j and j, or k and k, you do not have a value for that that part of the multiplication. So with this in mind, we can start doing a cross product. So now this equals, so I cross minus 3j, so I goes to j, which gives us k, and then because that's positive, we retain this negative sign, so that becomes negative 3k. Then I cross plus 2k, that goes backwards, so then we get minus 2j. Then we go for this value. So because j cross with j is equal to 0, we can completely ignore this multiplication. Minus 3j crossed with 2k gives us minus 6. And because this is going jk and is going the same way, is going clockwise in this cycle, we do not have an extra negative. So that remains as minus 6, and we get I. Finally, we get with minus 2k crossed with 2k, so that's 0. Apologies, minus 2k crossed with minus 3j. Minus 2 times minus 3, that's 6. But because we're going backwards, we get an additional minus, so that gives us minus 6i, and k cross with k gives us 0. So that is going to be our values for this multiplication. We can simplify that. We get minus 12i minus 2j minus 3k. So that is the first part of this question done, and that is worth 2 marks. Now proceeding with our second part, we are asked to calculate the equation of a Cartesian plane containing these two vectors, and the Cartesian plane also passes through this point. Now, when you're doing a cross product, you are essentially finding a vector that is perpendicular to both of these vectors. Now, because we have, let's take this as A, this as B. Now, because we're going, I'm gonna just change this and make this A and make this B. So if we follow the right-hand rule and we're multiplying A and crossing it with B, so our hand moves from A, wraps around to B, and our thumb is pointing upwards. So we know that the vector we get from the cross product is upwards, pointing upwards, and is therefore perpendicular to both of these, because it is not in the, let's say, the X and Y plane. It's instead is a normal to the plane is what we can say. And that ties in really well to our question because we're asked to find the Cartesian equation of a plane. So if A and B are two vectors on a plane, we also know that for any Cartesian equation, we know that these values, so A, B, and C, are also the vectors of its normal. So normal of plane theta is equal, so this should be an equal to. So the normal of theta is A, B, and C, which we get from here. So because these two are on the plane, and we know the cross product of them is perpendicular to both of them and is normal to both of them, we also know that this cross product is the normal of the Cartesian plane we are finding. So with that in mind, we know that the normal of, let's call it theta in this case, is minus 12, minus 2, and minus 3. Now let's try finding the complete Cartesian equation. So we know that the equation will now be minus 12x plus, or actually, sorry, minus 2y minus 3z is equal to d. Now we do still need to find d in this general equation, and to do that, we're going to make use of the coordinate that has been given to us, 1, 0, minus 1. So 1, 0, minus 1. So this is in the x, y, z coordinate format. So we can now plug these back into our equation. So we have minus 12 times 1, minus 2 times 0. Let me just, and minus 3 times minus 1 is equal to d. Now we can multiply this out. We get minus 12 plus 3 is equal to d. Therefore, d is equal to negative 9. So now that we have all of the unknowns of our Cartesian equation, we can write it out in full. So theta is now equal to minus 12x minus 2y minus 3z and is equal to negative 9. Now, because they're all negatives, I think we can also write this simply as 12x plus 2y plus 3z, which is equal to 9. And that solves the 3-mark part B of this question. And that is how you solve this question through vector multiplication and plane theory.